Hello. Wildfires are growing more intense across Canada. That's why we built BlazeWatch, an AI-powered tool that predicts wildfire spread in real time using satellite, weather, and vegetative data. Whether you're a firefighter or a resident in Canada, BlazeWatch helps you act before it's too late. Canada sees over 8,000 wildfires each year, burning more than 2 million hectares. In 2023 alone, 200,000 people were evacuated and thousands of firefighters, both domestic and international, were deployed. Fires are getting bigger, more frequent, and harder to control. Our tools support emergency responders, local communities, and environmental agencies. By predicting fire spread, we can help protect people, property, and ecosystems before disaster strikes. Our plan started by identifying the key factors that influence fire spread, like weather, vegetation, and geography. Next, we gathered reliable data to train our model using XGBoost for its performance in structured data and multi-target regression. Finally, we connected everything through a Flask backend and an interactive frontend to bring predictions on a map.
This is the demo for BlazeWatch. Let's go to the map. So what happens first is it makes an API request to NASA firms, which then returns the location of all the hotspots in Canada. We then group these hotspots by their distance from one another to visualize all the fires as shown here. The red are bigger fires, the orange are mid-sized, and the yellow are small. Now let's click on one of these fires to predict its path. Say this one. Give it a second to load. So what's happening here is it takes the 4 outer points of the fire and gets the weather data at each point as well as the vegetation and passes it to our Flask backend, which then passes it to our model, which predicts the next 4 outer points as shown here. And this can predict up to 3 days. You can see which direction the fire spreads as well as its growth or how much it shrinks. We cannot predict the exact perimeter or the exact shape due to limitations in both resources and time, but this will give people a general idea which is good enough to help them prepare for these fires. Now let's look at one more point, say this one. Give it a second to load. And we can see this fire is going to spread in the southwestern direction. It's going to grow a bit. Okay, so that concludes the demo.
Now moving on to how we made it. To get to the fire data, we used the 2024 fire perimeter and hotspots shapefiles and identified intersections as well as cross-checked dates to assign each hotspot to a specific fire and resulted in the following. We also used OpenMeteo's API to assign temperature, humidity, wind speed, wind direction, and precipitation to each point. Due to API and time limitations, we cut from 131,000 rows to around 5,000 by using the largest and smallest latitude and longitude values for a given day and filtering out fires with fewer than 3 points. The final pre-processing step was the most straightforward. The vegetation data was a text file, so we converted it to a 2D array with dimensions of 360 by 180, aligning it to the coordinate system and allowing us to easily assign the vegetation data to a hotspot for training. After, we applied one-hot encoding, transforming the categorical vegetation types into a format suitable for machine learning.
Regarding training the model, we standardized our input features using scikit-learn to ensure consistent scaling across variables like temperature and coordinates. We also evaluated model accuracy using RMSE for each output, ensuring our model provides the lowest RMSE possible. BlazeWatch is not just used for prediction, it's for preparation.